Okay, so now we're going to start our lesson on adding mixed numbers. So the first thing that we're going to need to do is change the form that these mixed numbers are in. And we're going to change them into improper fractions. So the first step is to change into improper fractions. And then I can give you an example of what an improper fraction looks like. It's when the bigger number is bigger than the top number is bigger than the bottom number. The numerator is bigger than the denominator. So how do we change a mixed number into an improper fraction? Good question. So the first thing I'm going to do is rewrite it. I'm going to space it out a little bit so that there's a little bit of space in between my whole number and my fraction. And then my first step is actually to multiply 7 times 2. So I'm going to draw a little multiplication sign, and I do 7 times 2, which will equal 14. So I write that right above. That equals 7 times 2 equals 14. And then I have to take that answer 14 and add it to my numerator. So I'm going to put a little plus sign there. So then 14 plus 2 equals 16. So I'm going to write that total answer then here. And the last thing I'm going to do is move over the denominator that I had originally. So I'm going to put that all over 7. So I'm going to do that one more time, but with our next mixed number. So I'm going to take 3. I'm going to leave a little space, write 5/7. And I'm going to start with my denominator, multiply by 3, and that equals 21. Then I'm going to take my answer and add it to my numerator, which equals 26. And then if you remember from the last problem, I just take the original denominator and stick that underneath. So now I have my 2 mixed numbers written as improper fractions, and my last step is just to add them. So I'm going to rewrite 16 over 7, and I now have to add it with the addition sign, and then I'm going to write 3 5/7 as the improper fraction that I found, 26 over 7. And then all I have to do is add them. When you add fractions, the denominators need to be the same. So goody goody, they're the same. And when that's the case, you keep the denominator the same. Okay, so since these both are 7, it remains 7. And this is for addition and subtraction of fractions. And then we just actually add the numerators. So I can do that work on the side. 16. So I got that from here, 16 plus 26. I'm going to add 6 plus 6 is 12, 2, 3, 4, so I get 42. So written as an improper fraction, 42 over 7. However, when a problem is starting out with mixed numbers, they usually want your answer to be in the form of a mixed number, which means we need to turn this improper fraction into a mixed number. To do that, all we need to do is take our answer then and divide. So if you remember from another video, when you're changing improper fraction to a mixed number, all you have to do is divide. You put the top number in the box, and then divide by the denominator. So I have to ask myself, 7 times what is going to give me 42? So I can do some of the multiplication facts for 7. So I might start with 7 times 5, which is 35. Then that's not quite enough, so I'll try 7 times 6, and that is 42. That's the one. So So 7 times 6 is 42, and I have no denominator, so my answer is actually just going to be 6. Now there is another way that you could have looked at this problem, but the next way won't always work. The way that I showed you first, this way will always work, and you can use this for any problem. The next way is only in certain cases. So what you can do first is you look at the fractions and you can add them. So we're going to take 2/7 and add it to 5/7. And then I get, if you remember for the rules of adding fractions, the denominator stays the same. And then you just add the numerators. So 2 plus 5 is 7, so I get 7/7. If you remember from other videos, any number over itself is just equal to 1. So 7 divided by 7 equals 1. So far, when I added these, I got 1, but now I have to add my whole numbers to that. So I have 1 plus 3 plus 2. So now I need to add this bit up. So 1 plus 3 is 4. 4 plus 2 equals 6. And you'll see that we got the same answer. But again, this method won't always work because you might not always have a common denominator. And sometimes they add up to being more than 1, and then there's another rule for what you do after that. So if you're looking for a consistent way to do all the problems so you don't have to remember so much, then using the first way is best. But if you understood the second way and it made a lot of sense to you and you can recognize when to do it and when not to do it, then you can definitely do this other faster way that I showed you. So now let's look at our next one, and as you can see, that first approach of adding the fractions won't work because now we have 2 different denominators. So again, we'll go back to that first approach that we were using. So I need to change my mixed fraction into an improper fraction. So I'm going to write 2 and leave a little bit of space and write 1/2. And then I'm going to multiply my denominator times my whole number. So 2 times 2 equals 4. And then I'm going to add my 1. So 4 plus 1 equals 5, and then remember I just keep my denominator and shift it right over. So my improper fraction for 2.5 is 5/2. Now I'm going to do the same process for 3 3/4. So I'm writing my whole number 3, leaving a little bit of space, writing 3/4. And then I'm going to multiply my denominator and my whole number. So 3 times 4. That equals 12. And then I take my answer and I need to add it to my numerator. So 12 plus 3 is 15. And then I just take my denominator and scoot it right over. So I get 15/4. So now we have to add these, 5/2 plus 15/4. But you might be saying, Miss Carol, wait. When you add fractions, they have to have the same denominator. So the next thing that we're going to do is use our strategy for finding a common denominator. So let's rewrite these using our strategy for finding a common denominator. So remember, we're going to stack them, 5/2 here and 15/4 here. And then we need to find a common denominator. So you want to start with the first approach, which is to find your smaller denominator and see if you can multiply that by anything to get our other denominator. So 2 times 1 is 2, 2 times 2 is 4, bingo! So I'm going to multiply this one by 2/2. So I can get 4 in my denominator. So 5 times 2 is 10, 2 times 2 is 4. So now we have 2 fractions with the same denominator and we can add them more easily. So let's write 10/4, and then we have to add 15/4, because remember, this is now the form of 2 1/2, and this one is the form of 3 3/4. So we have to add these two together to find out what this equals. So now if you remember, when you add fractions, the denominator stays the same. So I'm going to write 4 on the bottom, and then I need to add my two numerators. So 10 plus 15 is 25, because 10 and 10 is 20, and if you add another 5, it's 25. So then we're given 25 over 4. But if you remember from the last problem, if you start with a mixed number, you really want your answer to be in that same form. So we're going to transform this improper fraction. So I'm going to put 25 in the box and divide by 4, because remember that my top number always goes in the division box. So 4 goes into 25, well, if you do 4 times 4, that's 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, whoops, we went over, so it has to be this one, 4 times 6 is 24, 5 minus 4 is 1, 2 minus 2 is 0, so then now I have what I can use to make my mixed number. So the number on top is your whole number, so I'm going to write that first, 6. And then my remainder actually is going to go on the top of the fraction bar, and what I divided by goes on the bottom of the fraction bar. So now I have my mixed number, 6 1/4. So 2 1/2 plus 3 3/4 equals 6 1/4. And I can ask myself if that makes sense. So I have 2 and 3, so that's 5. So, and I have more than that. I have a couple fractions more than that. So I might end up getting more than that. So if I have 1/2, 3/4 is bigger than 1/2. So I'd know 1/2 and 1/2 is a whole. So then I'd have 6. And I know I'd have a little bit extra. So my answer does make sense.